Okay, we'll get started. Okay, so last class we were talking about policies. Airport policies were the example that we were using. We didn't quite get through it, so we'll just wrap that up and then we'll go on to the next topic. So we sort of ended at security. The main message here is there's different types of ways of examining. There's x-rays, there's metal detectors, there's a pat down, there's inspection of your bags, dogs, and chemical swabs. TSA mainly is concerned about anything that could harm the plane itself. They're not really concerned about border kind of items. We'll get to that in a sec. And there are exemptions to some of the rules. So you're not allowed to travel with liquids over 100 ml, but if you have breast milk or baby formula, that's exempt. If you have contact lens fluid, that's exempt as well. Another thing is usually when you go through security, they'll ask you to take your laptop out of your bag. Why is that? Any ideas? Guesses? Okay, but what about an iPad or a phone that has a battery too?
Yeah, the battery may be explode if it's too large.
Okay.
It hides other things in the bag because the rays can't get through.
Okay. So both of these are true. Oh, there's a sort of connection between all of them. So it does hide things, so it's hard for the X-rays to get through. iPads and iPhones do as well, to some extent, but laptops tend to be a little bit bigger in terms of form factor. The main concern is that, and laptops kind of look like a bomb in a sense. Like there's some circuitry, there's the battery, there's usually a liquid component to the battery itself. So on an X-ray, it doesn't necessarily look like a laptop. And so often you'll be asked to take it out. And the main reason they want to take it out is they used to make you turn it on to prove that it was a laptop. And it's just easier if it's not in the bag. So that was traditional. Now they don't do it so much anymore. I think because laptops got a lot thinner. But before you could try to hide some sort of bomb in the form factor of a laptop. You could also have it like turn on as well, because like you don't need, in order to turn the screen on, you don't need a lot of circuitry inside of it. You could have like a little Arduino chip or something like that, and you still have a lot of space left over, but more in like an older fashioned traditional laptop. So that was it. Another thing in the US is you have to take your shoes off. I think this is maybe changing now. So I think maybe in Canada you don't. I sometimes when I go to the airport, I never know. Sometimes no one takes their shoes off, and sometimes you have to. So it sort of depends. The reason for this is because someone tried to put a bomb in a shoe. They tried to ignite it on the plane. Somebody who was sitting beside them thought it was weird that they were trying to light their shoe on fire. They actually physically kind of tackled them, took the shoe away. They called security. The person was arrested and convicted. And now, after that incident, now everyone takes their shoes off. Okay? So say it's... Sorry, I didn't catch the first part of what you said.
I said, is it going boarding or when coming down? Because usually sometimes you might not take off your shoes, you try to board the flight.
Sometimes sorry, I not understanding for some reason, but when you're boarding the flight, you...
Like you said, sometimes you don't actually take off your shoes.
Oh, yeah. So that's right. So this incident happened in the US, so the US implemented it. Yeah. Canada, I think they did it right away as well. But then I think eventually a couple years went by, and then Canada's like, who cares? We haven't seen a shoe bomb in 2 years, so like forget about it. Yeah. But in the US, they kept doing it. And I think they still do it to today. But anyway, so Bruce Schneier, the person who brought all this stuff, like the contact lenses, and he wrote the article that is on the Moodle, which I recommend you read. He's very critical of security, and he's sort of part of his thing is that like TSA is not really doing a good job at stopping realistic terrorist threats. All they do is they react to what the terrorists did last week. The reason they do it is more for public safety, so people feel safe flying, and it's not really it's not like effective measures for reducing terrorism. It's more just to keep everyone calm and feel like there's stuff going on that's going to protect them, so they're not scared of flighting, essentially. And so he calls it security theater, this idea of like, as opposed to like really practical security. Okay, so we made it through security. That's good. Where do we go next? So there's two places we could go. One is we can go directly to the gate and get on the flight. The other thing is maybe we have to go through the border. Okay, so if you're flying from Canada to the US, you'll do this in Canada. You'll go to the border first, and then you'll be allowed to go to your gate. In other countries, you'll typically land in the country, and then you'll do the border security when you're done your flight on the other end. So let's just assume that we're doing customs before we get on the flight. So customs or the border, it obviously only applies if you're flying internationally. So if you fly from Montreal to Toronto, you don't have to do customs. At this point, they do check your passport. So this is the first time someone actually looked at your passport, looked at your face, and saw that you were the same person. But if you're flying domestically, no one does this check yet, either at this step, because you're skipping this step. They'll look usually at your flight details, or they'll type it in and they have access to it on your computer. They'll look at your status in terms of what your citizenship is, if you have visas, permits, that type of thing. What's the status of all of that? Terrorism is a consideration, but the border services are more concerned because they know TSA is trying to prevent terrorism. They're more concerned with other things that would go across a border that they want to have control over. So some examples would be drugs were mentioned last class as something that the TSA might be on the lookout for, but they're not particularly on the lookout for. Of course, they'll report it if they see it, but border will be on the lookout for it. Okay, so if they're inspecting your bags with dogs and that type of thing, they're looking for drugs as opposed to bombs. Any kind of other controlled substances, large amounts of cash. So in Canada, it's $10,000 equivalent. If you have more than that in cash, then you have to, it's not, for a lot of these things, it's not necessarily that you can't bring it across the border, but you have to declare it. And then they might levy a fine or a duty on it, or they might ask you questions about it or that type of thing. Okay, so you are allowed to bring stuff across a border. Not everything's prohibited outright, but you might have to declare that you're bringing it across, and then you might be subject to secondary screening. Let's say that you're detained at the border. Detained means that they'll take you and put you in a room, and they'll maybe call law enforcement, or they'll investigate you, or they'll question you. When you're detained, you basically have no rights. You don't have the right to a lawyer. They can detain you arbitrarily. So it's they can take your possessions. They can search your possessions. There's a good TV show, a fun one. It's called Border Services. It's Canadian. And it's like a reality show of border agents. And so every episode, there's usually like 3 or 4 cases where they show, some of them are funny and some of them are more serious and things like that. But there's things where like someone will go across the border and they'll be like, I'm here on a visitor visa. I just want to see Canada. I'm a tourist. And they'll say, well, why didn't you book a return ticket? Right? You say you're going to be here for 2 weeks and go back. Well, why didn't you book a return ticket? And they'll be like, they'll have some excuse for why. And then they'll say, okay, are you sure you're not here to work? And they'll be like, no. And then they'll be like, okay, give me your phone. You have to give them your phone. They'll say, type in your password or PIN. You're legally obliged to type in your password or PIN. And then they'll just start going through your phone. They'll go through your email. They'll find an email with someone who's like, looks like they're setting up a work contract for you. They'll call them up and they'll just be like, hi, I'm at the border services. I'm sitting here with this person. And they don't even have to do it in front of you. They can go in a back office and they'll just start calling people on your phone and being like, what do you know about this person? Why are they here? Where are they staying? That type of thing. And then they'll do their investigation. And then at the end of it, there'll be some conclusion. Sometimes you can voluntarily say, I'm not going to try to enter the country anymore, and then go back. Or you can try to enter anyway, and then there could be charges or like a travel ban from you going to the country or things like that. Okay? But the point is that they have a lot of power. Okay, even in some sense, they have kind of like more power than the police in a sense, right? So your rights are like kind of less than even if you were arrested by the police, and so they'll check everything. Anyways, yeah, and yeah, so your rights vary. Okay, so that's the border service. Also, like they'll look for things like there's a lot of like kind of things that you wouldn't necessarily think about. So like on the TV show, like a lot of people get caught like smuggling food across. That's like a big one. So why wouldn't they want food going across the border? Like say you have some, I don't know, tea or some plants and vegetables from somewhere, and you're trying to take them across. Something illegal. It's not like marijuana or something. It's just like lettuce or something like that.
Which is intrusion.
Yeah, exactly. So they're worried about like pests and insects that might be in the country that you're coming from, and they may not be local to Canada. And so that's the type of thing that they're worried about bringing across. So there's a lot of things like that where if someone goes to Europe and they try and bring cheese back or something, and then they have to get it thrown out.
That's my own person.
Yeah.
Let's suppose the team who is actually doing this stuff with the person. Do they always do the fair things with the person? Or like it's possible if I'm there and I'm right actually, but the officer is not good or maybe not that positive, and he's trying to put trouble on me. If this happens, or
Yeah. So, okay. So are the custom officers fair or are they corrupt? I'd say it varies from country to country. So certainly there are countries where probably border officers are corrupt. Yeah. And then in Canada itself, I think it's like pretty highly regarded, sort of similar to our law enforcement. I mean, there's bad apples in any like kind of enforcement agency where you have people with power, you're going to have bad apples in there. But I think in generally it's not like on a corruption index. There are some people that try to measure levels of corruption. I don't think Canada's particularly thought to be corrupt. Now, let's say you do have a dispute and you think you're right and they're wrong. The unfortunate thing is because your rights are so like limited, you can't really do anything about it other than go back to your country, and then you could file a lawsuit. And then you could say, okay, I wasn't allowed to go across the border for this reason. That's not a valid reason, right? And it will be heard by the court system, and then you may have a chance to overtake it. But it's not like if you have to be there next week, that's not going to work, right? If it's like I'm moving there for a job, they're not letting me across the border because I'm on a list or something like that, you could get that overturned in theory, but it's the kind of thing that might drag on for 2 years or something like that before your case is ever heard. Yeah. So there is a way to sort of appeal the decisions, but it's like a long process, not a short one.
as I see like everyone implement rules and they're good for the public, but the implementation the person doing is this they're doing or not, it depends on the person actually.
Yes.
So I'm asking you like you mentioned like in airports now they take off your shoes, and the way I was there in Pakistan it not happened with me in the way they took off in Canada now. So I think it depends mostly on the officers who are on the position right now. Either they do check or do not. Even they are low, like you have to take off shoes of every person, but they actually took some of them and some of not.
Correct. Yeah. So it's also down to the officers, and some officers are more lenient, some are more strict, some follow the law closer, some are going to give you a hard time, and that type of thing. Now, whether they're all within the bounds of what they're allowed to by law, like they have to cross over before it's considered corruption, right? But definitely, yeah, there's definitely a wide variance in terms of officers themselves. Yeah. Yeah. So if you're on the no-fly list, you shouldn't have gotten this far in the process. But
Asking in case near the border, if the customs officers find out that you're not here for actually tourists or you're here to work and then ban you, so this is how the ban list go to the no-fly list?
I see. Yeah. So I don't know all the ins and outs of it, but I imagine that there's two lists. So when we normally talk about the no-fly list, it's only like terrorism related, and that's it. Yeah. But there's also a list of people who are not allowed. It's not that they're not allowed to fly in general. It's just that they're not allowed to come to Canada, right? They've been blocked from Canada. And usually it has a time limit, like 2 years or whatever. So border services will update that list, right? But if there is some suggestion of terrorism or something like that, they're probably authorized to update the no-fly list as well. So they're probably the people that are putting people on the no-fly list, along with traditional law enforcement and along with like spy agencies and things like that. Yeah. So I think it seems, especially in the U.S., like there's a whole bunch of different agencies that are allowed to add names to the no-fly list.
Okay, so once they are on this no-fly list for this particular reason, that will be applied to all the different countries, no, right? Only this one particular country.
Yeah. First, by default, it will only update in that particular country, but countries can share information. So one of the slides showed that we subscribe to a US list. So there's a list that the US is creating and we're using it in Canada. Yeah. We don't have to use it. We're not legally obliged to, but we choose to. Yeah. And then generally there's like 5 nations called the 5 Eyes. So it's like Canada, the US, England, I forget the other 2, maybe France and Germany, something like that, and or Australia maybe. But anyways, they tend to share. Yeah, okay. But they tend to share information across, so they probably have joint no-fly lists, or at least if one country adds someone, they'll probably circulate that to the other countries. Yeah. So probably most likely. So no one can tell you for sure because it's like top secret classified. But that it makes sense that would be the case. Okay, now you're finally ready to get on the flight. So normally when you get on the flight, you're going to show 2 things. You're going to show your boarding pass, which they'll scan. They'll pull up the record of your boarding pass from their back-end database, okay? So they'll see, it doesn't matter what's printed on the boarding pass. You might have, you might have changed the boarding pass. We talked about how that's possible. You might have given yourself a seat in first class. The database is going to show where you're actually sitting, okay? So you can forge the boarding pass, but you can't forge the back-end database. But anyway, so pull your boarding pass up. It will have your name. They'll take your passport. They'll basically do a 3-way check. Does your face match the face on the passport? Does the name on the passport match the name in the back-end database? Sorry, 2-way check. And assuming that all of that is good, then you'll be allowed to board the plane. Okay. Now, assuming that we're flying domestically, this is the first time someone actually looked at your passport. Okay, lots of people looked at your boarding pass, but nobody has looked at your boarding pass until now. Okay, and the ID that you need in this case will depend. Also, if you're flying internationally or domestically. So if you're flying internationally, a passport. And if you're flying domestically, some sort of other ID is fine. Any government-issued photo ID is okay. So if I fly from Montreal to Toronto, then I can just show a driver's license. I don't have to show a passport. Okay. The next thing I want to talk about is something that was historically true. I'll tell you kind of the story about it, but it goes back to this idea of policies. So in the US, they used to have a rule that if you're flying domestically, they wouldn't check your ID. They would just check your boarding pass, and that's it. And so this created a loophole where basically you could, when you check in, they'll check your boarding pass and that your name isn't on the no-fly list. In the US, they do tend to do a screening that happens before you join the security line. And there they were doing an ID check. So you would show your ID and you would show your boarding pass. The problem is that the person doing this screening, they were TSA, they weren't the airline. And so they had no idea like whether this boarding pass is real or not. Okay, they don't have access to Air Canada's database, but they're basically just checking your ID and making sure your ID matches your face. Then when you board the flight, this is what should happen is they're going to check all 3 of those together. Okay, and if they're checking all 3 of them and doing a good job, you don't really need the optional screening in between. Okay, somebody's checking all 3 of them. Okay, but what was happening in the US was that when you boarded your flight, they weren't checking your ID. Okay, so it went from them checking all 3 to just checking basically the same thing that they checked when you checked in, which is the boarding pass, and the no-fly list, which was already checked. Okay. So this created a problem. The problem is basically what an attacker can do is, because boarding passes have no security, you can forge them. Okay. So the attack is you actually create two boarding passes. You have one boarding pass that's in your real name as someone that's, say, on the no-fly list and you're not allowed to fly. Okay. So that's your fake boarding pass, but it has your real name on it. And then you create a second boarding pass. The boarding pass is for someone else. You just pick someone, you register a ticket in their name. So you have a boarding pass for them. And that person is not on the no-fly list. Okay. So then what you do is you show up and you go to check in. And so what you do is you get the other person's boarding pass. Okay. And you have it. And anywhere you have to check in and show the boarding pass, that's the boarding pass that you show. Okay. Now, when you go to that optional screening, the security screening, they want to see your passport. And we're going to assume that you can't fake a passport. That would be another way. Obviously, if you can fake a passport, then none of this matters. So what you do is you give them your other boarding pass, which is fake. It doesn't correspond to a real flight. The person on that boarding pass is not on the flight. Okay? But the person that's looking at this is TSA. They don't have access to the flight database. Okay? So they look at the passport. They look at your face and make sure you're the same person. And they look at your boarding pass and just make sure the name matches what's on the passport. But they don't know that you are not on the flight. And they're not checking in real time against the no-fly list because that was already checked. You wouldn't have got a boarding pass in the first place if you were on the no-fly list. Okay? Then you go through security, blah, blah, blah. And then when you get on the flight, you go back to your other boarding pass. You show them the other boarding pass and you get on the flight under someone else's name. Okay? So this is a loophole in the policy. It was pointed out by Chris Segoyan, who's a security researcher. He wrote a paper about it. He also created a website where you could create fake boarding passes just to demonstrate that there's no security on boarding passes. And then his door got kicked down by the FBI and they seized all his computers. And eventually, I think he was able to get them back. But anyways, they weren't particularly happy about it. And then the US very quickly changed their law so that you required an ID check at the last step. So they went from this to this. So in the boarding flight, you have to check all three. Okay, so this is why these policies are important, is because when they get really complicated and you have, in particular, you have different people checking different things, right? Sometimes you don't have the proper overlap and there isn't a holistic check of all the information. Okay, so this is just some articles about him getting the FBI coming and then TSA changing their rules. Okay, so in terms of policies just in general, so we did this big example of airports, but what are the sort of takeaways from them? So one of the challenges with policies is when it gets split across multiple organizations, okay? So you have the no-fly list, that's sort of by the government. They're interfacing with the airline to do those checks. The airline has access to who's on the flight. TSA doesn't have access to that. Border services, they're looking at your passport. They know a lot about passports and fake passports and that type of thing, but they don't necessarily do the check of whether you're on the flight itinerary. And so because different people are checking different things, it's possible that maybe you show the right combination of things to different people. So a fancy word for this is equivocation. So the assumption is that you have one boarding pass and you're going to show the same boarding pass to everyone. And then eventually you're going to get caught, either because you're on the no-fly list and using your real name or because your boarding pass doesn't match your actual passport. So, but this idea of showing different things to different people, we call that equivocation. And there's a lot of attacks in cybersecurity that you can see that are equivocation attacks as well. So it doesn't just show up in this context. Generally, the more complicated a system gets, the harder it is to check whether it's secure, and the more likely there's going to be some sort of loophole that you can exploit. So simple rules tend to be better or easier to check. So how do we solve this? What's the methodology for fixing it? So there is no good methodology. So I like to cover a few things in this course where they're sort of like to-do items because there's no actual great methodology for doing this. There are a few things that people do in practice. So one is you could hire people to try and figure out how to get loopholes through your system, kind of like a red teaming exercise, but they're going against your policy as opposed to your implementation. Now, these external audits can take a lot of time. And another thing too, we talked about ethics clearance when we talked about usability. If you want to do this for something, you should get ethics clearance as well. You have to in a university context. And the other thing is that at the end of the day, when you have your audit and the audit passed, you can really only say one thing about that policy. So you can say, okay, this policy is okay, but if another company wants to implement a policy, it's going to be slightly different, and then you'd have to redo the same exercise for it. So that's another problem. You don't have like standard policies across the board. Another solution is right now we pay people to find vulnerabilities. Generally, companies do that. They have a bug bounty. You could do the same thing with policies. Find a flaw in our policy. Instead of sending the FBI to kick down your door, we'll give you $10,000 for pointing it out. You can do regulation, so the government can step in and say, okay, we have certain rules. You have to operate in certain ways. So the SIM swapping example we talked about, that's now something where the government's getting involved because there were a lot of problems with SIM swapping. And so they're sort of setting up some regulations about things about how companies have to handle them and authenticate users and that type of stuff. You can do whistleblowing, so you can just go to the press and talk about what happened. And another thing you might think about is we have really good tools for like software, right? If you have software and you want to know whether there's security vulnerabilities, you can do all sorts of static analysis, fuzzing, dynamic analysis, control flow stuff. So we have all these automated methods. Those don't work on policies because policies aren't code, right? But what if we took the policy and we wrote it up as if it were code? Okay, so we call that formal methods or formal verification. It's basically taking something that's not code, like a policy or a procedure. It's not just that. You use it for all sorts of things, like take a math theorem. But anyways, the point is to translate it into code that's machine understandable. Then now that it's in code, then you can run software on it. And you can have the software, you can ask software-based questions. Like, is it ever possible for any one person to do this one goal given that all these rules are in place? And they'll say, oh, there is this one instance if they have two fake boarding passes or whatever, and it will find these like kind of flaws. Okay. Now, when you model something as code, if you miss something in the code, like if the code representation of the actual policy is different, then you're not going to find flaws. You could miss flaws that are related to whatever those differences are. So this method is only as good as the model is accurate. Again, you can do a formal model for one thing, but you can't really translate it to other policies. So like everyone would have to do it from scratch, more or less. There's not going to be a lot of reuse of the models. And there was one other thing that I was thinking of. I thought I had a bullet point for it, but it's escaped my mind. So anyways, we'll keep it at those two things. So it's hard to reuse, and it's only as good as the model itself. Okay, so that's what I wanted to say about airport security. We'll pause if there's any questions about that, and then we'll move on to browser-based policies. Okay. Okay, now another example of policies are in more technical policies that are in code, but they're still policies in the sense that it's a rule that some human decided. They decided it should work this way instead of working this way, or we should do this instead of this, Okay, so that's what kind of makes it a policy. So when we talk about web browsers, who is it that sets the rules for how a browser works or even how the internet works more generally? And usually it's the vendors themselves. Okay, so the vendors that are making the browsers are the ones that are going to sort of set your rules. Who are the different browser vendors? So browsers sort of came out in the 90s. Before that, you do more like command line kind of internet stuff. So there was www, Mosaic. Netscape was the first popular browser. Okay, it became very, very popular, and it was the dominant browser. And then Microsoft said, "Oh, we should do a browser too. Lots of people are running Windows, but they're running Netscape Navigator on Windows. Why don't we make a browser to compete with Netscape? We'll put it in every copy of Windows. Then people aren't going to install Netscape because they already have a browser." So they came out with Internet Explorer. Apple did the same trick a little later, so they came out with Safari. Firefox was so Netscape kind of died at a certain point, and then Firefox took, I believe, some of the IP from Netscape and turned it into a new browser. By this time, everyone was using Internet Explorer or Safari, and Internet Explorer in particular was really slow. So it was like really bogged down. Think of Microsoft products like Word and things like that, like really heavy. And so Firefox was really light and nimble. And so it became very popular because it was so much quicker and more responsive. And so lots of people started installing it. And then Google came out with Chrome. And by the time Chrome came out, Firefox had also got kind of bloated. And so people, again, were looking for something that was kind of lighter weight and more nimble. And so then Chrome was sort of the answer. Plus, it was Google. This was sort of at the height of Google having Gmail and a bunch of services that we use now. But at that time, they were new. And so the idea of having that integrated in the browser was appealing to a lot of people. So Chrome became dominant. Then, ironically, Chrome also got really bloated. And so I personally stopped using Chrome. I don't know what it is like today, but there was a certain time period where it was just so slow, especially on the Mac. And yeah, exactly. It would just destroy your RAM. And if you left it sitting open and you didn't exit it for 3 days, then your computer would crash because it would just have it would eat all your RAM. Yeah. So I'm sure it's better now. But anyways, I went back to Safari, so I use Safari myself. But anyways, Chrome, Internet Explorer, Safari are popular. Chrome is popular now also because you have Android. So default on Android devices, which is the biggest or second biggest operating system for phones. You have Google Chrome OS as well, but it's maybe not. Chromebooks aren't so much popular. Internet Explorer obviously is still very popular. I guess it's now called Microsoft Edge. So here's the sort of browser share. So you can see most people these days are on Chrome, 66%. This is only for desktop, not for mobile. And then people running Windows using Edge are sort of in the minority. And then there's people that use Safari. Mozilla is still around. Opera is another one of those lightweight kind of browsers. Okay, so Netscape, as I said, they were kind of the big browser to go mainstream, okay, and around 94. And so Netscape made some decisions back in 94 and in 95 that other browsers hadn't made decisions about, okay? And so they introduced some technologies, made some decisions. And then when Internet Explorer came out with their browser, they basically copied Netscape's decisions. And then every browser since has copied it. Okay? So what was decided in 94 and 95, we still see on the web today. Okay? And there have been some problems along the way. It's been a bit of a bumpy ride in terms of what they decided. So there's two policies in particular that have had consequences up to today. One of them is it concerns cookies. So cookies you know a little bit about from assignment 2, but we'll go through the details of it and then we'll talk about the policy. And the other one has to do with scripts. So websites will run scripts. You might have scripts loaded from different websites running on your website. You're on a website and there's 5 scripts running from 5 different places. What's the interaction between those scripts? Can they talk to each other? Can they see each other? Can they change the content of the website? Do we want to isolate scripts from each other? And so there's going to be some policies that are set in terms of how things get isolated from each other on a website. So that one we'll talk about next class. It's called the same origin policy. Cookies have a similar, you could almost call it a same origin policy because the origin of where you get the cookie from is sort of the deciding factor in how cookies will behave. But we'll see. Okay, so before we jump into cookies, where are cookies in terms of, like, I go to a website and there's some cookies that are involved, like where are they in terms of it? Are they part of the website itself or are they outside of the website? Okay, so the website, the stuff that you're seeing like on the website, that we call the content of the website. Before, when we were talking about TLS and HTTPS, we mentioned that there's active and passive content. So passive meaning it doesn't run scripting, and active meaning it runs scripting. And then you have a bunch of headers. Okay, so headers, think of it as an envelope. So the content's in an envelope, and then the headers are what's written on the outside of the envelope. So they're not part of the content of the website, but they are being exchanged every time you go. And the browser is creating the headers. Okay, or the server, the web server, if it's sending it to you. Okay, and so things that you find in the headers would be cookies, information about the user themselves. So a lot of times, like say I'm going to a website, my website will tell, or sorry, my browser will tell the website, hey, he's running Safari version whatever on operating system whatever. Okay, so that's called the user agent. And it's good for the website. They get that information and they might say, oh, you're on a desktop as opposed to a phone. I'm going to send you the desktop version of the website. Or I see you're on a phone, so I'm going to send you the mobile version of the phone. There's refer headers. That's another thing. So if you're on one website and you click on a link, you go to a different website, your browser will tell the website you're going to now what website you were on when you clicked it. So it can sort of track where you're getting the links from, and it just helps them like sort of understand who's linking to them and things like that. And then there's a whole bunch of other headers. Okay, there's tons and tons of headers, but anyways, these are just some examples. The main point for now is that cookies are in the headers themselves. They're not in the actual content of the website. Okay, we have some security goals for websites in general. So forget about cookies for a second, but just in websites and we can relate it back to Stride. So if I'm a web server and I send you a website, I want you to see the website as I intended it, right? If I send it to you and it looks a certain way, then when it renders on your browser, it should look the same way, okay? So that's a basic goal. I don't want it tampered with in the middle. I don't want you to see something completely different than what I tried to send you. If I'm sending information to multiple, let's say I have multiple tabs open and I'm sending information to a bunch of different websites, whatever I send to Google, Facebook shouldn't be able to read. Okay, sort of makes sense. It's sort of obvious, but that's another goal. Okay, now let's talk about cookies for a second. Okay, so let's say I go to Gmail. It asks me to log in, so that's fine. So I type my username in, I type my password in, I press enter. The password gets sent, hopefully over HTTPS. Okay, server takes my password, they hash it, they compare it to their database, which they have registered for me. And if the hashes match, they say, yes, that's Jeremy Clark. I'm going to log him in. I'll send him his inbox. So now I'm looking at my inbox. And I see the first message in my inbox and I click on it. Okay. Now what Gmail is going to do, now it's really fancy, like it happens in client-side scripting, blah, 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 blah. But let's go back to like older, like HTML base. Pretend that I send a request that basically says, okay, give me the first message. I just clicked on the first message, and then it's going to send me back a new website that has that first message loaded. Okay. The question I have is, I didn't have to log in to see that message, right? I logged in to see my inbox, but then once I click on the first message in my inbox, it's not like I have to send my username and password again. So how did Gmail know that I'm the same person that just logged in? Especially considering that there's 10 million people that are using Gmail at the exact same time as me. I'm coming from Concordia's Wi-Fi. There's probably, thousands of other Concordia students that are also on Gmail at the same time from the same Wi-Fi. Okay, so it can't be based on IP address because we all share the same IP address, right? So what is it? How do they establish that continuity between this is the person that asked for their inbox and now this is the exact same person that's asking for that first message?
The kind of ticket in your browser and city timestamp like for a certain time, so it will be expired after a certain time.
Okay, so they store a ticket in my browser, and then every time I go back to the website, I basically show that ticket. Okay, so yes, that's basically the idea. What do we call that ticket? A cookie, okay? So that's what a cookie is. So a cookie is a piece of information. The server sets it on my computer. So basically when it sends me back my inbox, it puts a cookie value as well in the header of that response. My computer takes that cookie value, it stores it, and when I go back and click on the first message, my browser takes that value, it puts it in the header of my request, and Google says, I know who this person is because I've seen this value before. Okay? Now, it's important that this value is kept secret. Okay? Because basically, what would happen if I stole your cookie value and I said, show me the first message in my inbox, but I sent your cookie value along with that request, then they're going to show me the first message in your inbox. Okay? So if I can steal your cookie, then I'm essentially logged in as you. Okay? So we call that session hijacking. So session hijacking is just, I take your cookie and I put it in my cookies and I send it. And then now it thinks that I'm you. Okay? Now this isn't the only purpose of cookies. Cookies are used for other stuff, which we'll get to in a couple slides. But anyways. Okay, so a cookie is, it's a number. Technically, it's a key value pair, meaning like there's a name or a tag, and then there's a number. Okay? The website is the one that chooses it. You don't choose it as a browser. The website chooses it, and it asks you to store it in your browser. So it says, I want you to store this number, this value, and give it the name session ID. And then, by the way, a website can get you to store lots of cookies. Okay, so you can have different cookies, and you can tell them apart because they'll have a different key or a different name. Okay, so a website might set 10 cookies, they'll all have different names, and then they'll have different values. The browser will store the cookie, okay, unless if you override it, you can control what your browser does if you want to. But by default, your browser will store the cookie. And it will also write down who gave it to them, okay? And so it will say, okay, the user was on mail.google.com and it received this cookie. So I'm going to put this cookie in my data store, but I'm also going to note that it was mail.google.com that gave it to me, okay? So that's called the origin of the cookie. So the origin of the cookie is basically who was it that asked you to set that particular cookie value. And this will become relevant to the cookie policy in a second. Then what the browser will do is every time you go back to the website, it will go through its jar of cookies. We call it a cookie jar. So it goes through the cookie jar and it just says, okay, do I have any cookies that belong to this website or that this website asked me to set? And I'm going to send them along with all outgoing requests. Okay. Now, exactly how it decides whether to put a cookie in or out, that we have to talk about because there's some details. But in general, it's going to try and send, it's not going to send your Facebook cookie to Google, but it will send your Google cookies to Google every time you go back to Google. But we have to work out what exactly that means. Okay, so which cookies does it send and when? That's what we need a cookie policy to say, like how that works. Okay, so here's how it kind of works just in terms of a diagram. So I go to mail.google.com and I say, give me my index or my whatever, give me my inbox. And let's say at this point I'm not logged in. So what Google has is they have their backend database of all their users, and they have the usernames, they have the passwords, and now they're going to have a cookie value as well. Okay, so a cookie value, we're going to call it SID, which stands for session ID. And it's just like a password. okay? But it's a password that instead of the user typing in, the browser is going to put in automatically, okay? Now, if Alice has not logged in to mail.google.com, say she gets a brand new computer, Google's never seen this person before, they're not logged in, they don't know who that is. What they'll do generally is they'll still give them a cookie value, okay? So they'll say, I don't know who this person is, so I'm just going to have them as unknown user, and this is the cookie value I'm going to give them, okay? How do they give the cookie value? Oh yeah, and this needs to be like a large random number. You shouldn't be able to guess it. If I can guess your session ID, then I can impersonate you. So I shouldn't be able to just try random numbers until I get the right one. So it has to be long enough and random enough. So when Google sends its response, like welcome to Gmail, like please put in your username password, in the header of the response, it's going to have a command set cookie, and here's the value. So it gives me this value, and then it can name it whatever it wants. So it might name it SID for session ID. Okay. And so now my browser, or Alice's browser, oh yeah. Another thing is because these are secrets, so A, they should be large and random. Second, you should only pass them around over HTTPS. If you pass them over HTTP, then anyone can read that value, right? And they can just lift it off the wire, okay? And we'll talk about that in a second. Actually, I think we'll talk about it right now, yeah. Okay, so what would happen if, this is the way the web used to work. The web, you would go to Gmail and it would say, okay, I'm about to take your password off of you. So you better, we better establish an SSL connection. So then you'll go to the secure version of Gmail. You get redirected if you aren't there already. There'll be the lock, there'll be HTTPS. They'll take your password off of you. And then when they log you in and show you the inbox, they flip you back to HTTP, okay? Because the password authentication is done, right? Okay, but the problem with that is now that you're logged in, you have this session ID, and you're going to be showing the session ID, and as long as you can show that correct session ID, then Gmail will keep showing you your messages, okay? So that model is not good. Because someone could hijack it in the middle. Now, I don't know that Gmail was actually vulnerable to this. I know Facebook was, and Twitter, and a couple other like social media websites. But what they said is that, yeah, we understand that that's true, that someone could lift that cookie value off the wire. But A, they would have to be a man in the middle. So it's a pretty sophisticated attack. They would have to know how to do that. They would have to go in and get that value out. And so we're talking about like an elite level hacker that could do this attack. True, it works in theory, but we're not protecting our users against elite level hackers. We're just, we're trying to maintain like a good level of security, but balance it with performance as well. Okay, so that was sort of the thinking in social media for why the websites were set up this way. Then what happened is one hacker made a tool, and the tool was called Firesheep, and it was an extension that you could get for Firefox. So it's just a browser extension. You don't have to know anything about installing it. You would just download this Firefox extension called Firesheep. Now it's a button on your browser. And what you could do is you could go on any public Wi-Fi. Say you go to Starbucks, you open your laptop, you open Firefox, you press the Firesheep extension, and what it would do is automatically it would poison the router table of the Wi-Fi network that you were connected to, or the router. And it would basically get everyone putting their traffic through your computer, through your IP address. Okay? So it would do this spoofing, and then now you're actually a man in the middle. Okay? Everyone's running through you. And then what it would do is it would inspect the traffic, and it would see if anybody else was on Facebook. They could tell because the traffic's not encrypted, so they know they're going to Facebook. It would lift the cookie value out, and it would grab their username and their picture, their profile picture, and things like that. And so what you would experience as a person using the extension is you just go to Starbucks, you press the extension, you wait, a little bit, and then all of a sudden these profiles start popping up. Jeremy Clark with a picture and all of you with a picture. And if you wanted to log in as that user, you would just double click it. And then now, boom, you're into their Facebook account. okay? Because it grabbed the cookie and it inserted it, injected it into their traffic, okay? And so this attack was always possible. Everyone knew that it was possible, but people didn't think it was easy. What Firesheep did is it took it and made it so simple that anyone could do it. And you better believe everyone was doing it, right? Everyone installed it, and just for fun, like probably not like trying to be super malicious, but they would go to Starbucks and try it out and see that it works. So what do you think the social media websites did? Well, they turned on HTTPS right away. Okay, they said we can't have that. So it was like, anyways, it was big news. Again, this is sort of like national level news thing. Like you could turn on CBC and there would be like some article about Firesheep. It wasn't like some obscure hacker thing. And then as a direct response, social media started putting their websites on, not just taking your login off of HTTPS, but once you're logged in, you just stayed on HTTPS forever. Okay, so all your cookies and stuff would go back and forth over it. Okay, so anyways, back to this diagram. So I send my request, I get my response back, but in the header of the response, mail.google sets an ID. They update their backend database with this ID as well. And then what I do is on my browser, what Alice does on her browser, is she's going to add this cookie to her cookie jar. Okay, so she's going to say, I was on mail.google.com. It wanted me to set cookie named SID with this value. Okay, and it's going to sit in the cookie jar, and cookies eventually expire. We'll talk about that later. Yeah. Yeah. So there's two ways that a time bound could be put into place.
Mostly what it does is that the cookies are always on the run. So if you restart, it's going to be more like you're starting the session again. So two things. Is it going to give you a new session ID? And is it time bound? Is session time bound?
Yeah. Okay. So there's a couple answers to this question because there's a couple different mechanisms, and websites use all of them. Okay. So the first thing is that when you set the cookie, I'm simplifying it, you're setting two things here, but there's some other stuff that you're going to set. We'll see it in a couple slides, but one of them is an expiration. So in the cookie itself, you can say, I want this cookie to live. The shortest that you can ask it to live is what they call session, which means until the browser restarts. So once the browser quits and restarts, then your browser will actually remove it from the cookie jar. Okay? But you have to restart your browser in order for that to happen. Okay? So that doesn't mean navigating away from the website and coming back. It means closing the browser and then coming back.
If I have my network was a bit where I have to boot the router, my system is still I'm still connected to
Yeah.
the website, but I have a bit of a timer. So I refresh. I didn't close it. I just refreshed the browser. So it's going to continue the session.
Yeah, it will continue the session. Yes. Yeah. Because refreshing and say I click on message 1 and then message 2. Or I click on something else and then refresh. It kind of looks the same. Like you're getting requests, and there's a time distance between them.
After the timeout, I can impersonate the person.
Okay, so let me get through all the timeouts because there's more than that. Okay, and then circle back to that question. So in terms of the timeout that's in the cookie value itself, either the browser closes or I set an explicit time, and then once that time passes, then the browser is going to be the one to stop sending the cookie. So my requests will go, but they won't have a cookie with them. Okay. The other thing is the website can also implement timeouts. Okay. So my browser will keep sending the cookie, and the website will keep seeing the cookie. But what the website can do is when they set the cookie in their backend database, they can say, this user, they didn't click always keep me logged in, right? So when they click the logout button and I see a request for the logout button, I'm going to delete the cookie from my backend database. Again, but the browser doesn't know it. It thinks the cookie's still valid. It keeps sending it, but the backend server is going to say, I don't honor that cookie anymore. And then yes, it will send you a new cookie type of thing. Yeah, does that make sense? Okay, so the browser you can see Another thing you can do is you manually can go in and delete cookies anytime you want. You can clear them all, or you can clear them for a website, or you could set your own time limits or things like that. Yeah. So if you're sitting at a public computer, like a library kiosk, you could clear all the cookies before you log out. Now, logging out and that should not give your cookie jar to the next user anyways, but if you were paranoid about it. Yeah, so anyway, so server side, you could have policies, and then cookie client side, and then hopefully they're in line with each other. But the main point is you have no idea what's happening on the backend server. I can't see it, so I don't know. I'm trusting that the website is doing, if it says, if I don't click keep me log in and I log out, I'm trusting that it's not honoring that cookie anymore, but I don't know it. I can't see it for myself. Yeah, but my cookie jar I can see, and if I delete it, I know it's deleted. Does that make sense? Yeah. Okay. So now what happens is I go back to Gmail and I send my next request, give me my first message or whatever. And then my browser's like, well, wait a second. I see that you have a request. It's going to mail.google.com. Let me look through the cookie jar really quickly and see if I have any cookies for mail.google.com. Oh, look, I have one here. So I'm going to throw that in to the header, and then that will go along for the request. Then Google will receive it, and they'll say, okay, I just got a request. It has this cookie value. Let me figure out who this is. So it will go in its backend database. It'll be like, okay, I found the cookie value. So I know that is somebody. It's not a made up value. It's in my database. But I actually don't know who that person is, but that's fine. I at least know that this is the same person that was on the page previously. I don't know what their name is or anything like that, but I know that they're the same person that's coming back. Okay, then at some point, Alice might say log in to Gmail. And then Gmail's like, oh, I know who Alice is now. In fact, I already have her, and I have a different session ID for her. Maybe that's because she had an old computer, or she cleared her cookie jar, or she has a phone that has a Gmail account and she has another computer. You can have multiple session IDs with the same web server. There's lots of reasons for it. But now it's like, okay, I know who Alice is, so I can kind of merge their profiles. I can put Alice's name here. I could put her password here as well. I know this is her cookie value. And by the way, everything that Alice did up to logging in, the web server could have written down what she did. It didn't know it was Alice. It was just like unknown user clicked on this, unknown user clicked on that, then they did this. And then 6 months later, Alice logs in, and all of a sudden it's like, oh, that person who has this 6 months of history, I now know who that person is. I know it was Alice all along. And so it's not just like Alice reveals her identity at the time she logs in. She actually kind of backfills all the things that she did, assuming that cookie was persistent across it. Okay? As long as she doesn't delete it.
No, I'm saying from the back end.
From the back end,
If that session was deleted.
yeah, exactly. Yeah. So as long as the session, now even, this is another thing, is let's say you are interested in tracking your users. It's good, you make money off it, you can sell data to other people. Let's say a user says, I want to log out, I want you to forget my cookie, right? You're probably not actually going to delete it, okay? What you'll do is you'll stop treating it as a login cookie, but you're still going to save it, and you're still going to use it to track the user, because the user is going to keep sending the cookie, right? And you'll be like, well, I know who this person is. They told me to log them out, so I'm not going to log them in because I see this cookie value, but I still remember that I gave this cookie value to Alice. And so I can still track her with it, yeah? But you could also just send a tracking cookie anyways, and websites do all sorts of things. Okay, so users, you can block cookies if you want. And so your browser just won't add any cookies to the cookie jar. You can block, for example, third-party cookies. So a third-party cookie would be like you're on mail.google.com, but Facebook wants to set a cookie or something like that. You can clear your cookies at any time. So if you accept cookies and you let them go in your cookie jar, but you want to clear them, you can do that. You can set your browser so that every time you close your browser, it wipes the cookie jar. That's not the default behavior, but if you want that, you can set that up. You can go anytime and clear all your cookies. if you want, let's say that you want to go to a website and it's as if you deleted all your cookies, but you don't actually want to delete them. The problem with deleting all your cookies is that then you're now logged out of all your websites. So now you have to go and you have to log in to everything again, okay? But maybe you want, for some reason, you want, kind of like you installed a brand new browser, you don't have any cookies set, but you just want it sort of in a temporary session, and then eventually you'll go back to your old browser where all your cookies are. That's exactly what private browsing mode is, okay? So if you open a new private browser mode, it starts with a clean cookie jar. There's no cookies, okay? As you use private browsing mode, it will put cookies in the cookie jar. So it will build up cookies as you browse with it. But then when you close the window, it will delete those cookies, and then you'll just go back to your normal browser with whatever cookies it is, okay? So if you ever want to do things without having your cookies follow you around, that's what private browsing mode does. It's also useful in sometimes if you're debugging things. Sometimes things get buggy. Or let's say you want to, like someone's sitting down to my computer, they want to check their Gmail. Instead of signing me out, because that's kind of annoying because now I'm signed out of Google Docs and all this stuff, what I could do is just open up private browsing mode. They can log in, check their Gmail, they can close the window. I don't have access to their account, and they didn't have to log me out of my account, and I'm still logged in, okay? So private browsing mode has all sorts of different applications. So expiration, we talked about. Basically, the cookie value itself, you can set an expiration. The browser will honor it. The user in the settings of the browser can set expirations as well that may be different than what's in the cookie itself. And the server can always decide to not honor a cookie at any time it wants. Okay, so expiration is sort of controlled by all three of those things. Another thing you can do, as you saw in assignment 2, is you could install a tool that gives you more control over your cookies. Okay, it lets you see them. You can, instead of having just these options, you might be able to do fancier things with it. And so you can basically have more insight into what cookies are being set. You can have more control. You can remove them on a per website basis, that type of thing. And then as mentioned, the server at any time can clear the cookies, but the client doesn't know whether that happened or not. Okay, so what does a cookie look like? So let's say I go to a website like tsn.ca. You can see this is a pretty sort of noisy website where it's setting a lot of cookies. And it's not just from tsn.ca. There's other things that are running on TSN's websites, like ad libraries from Google and things like that. But we'll deal with, so these are third parties in this case, and then this is the first party. My browser actually says tsn.ca. I can demo this. I'll just go through the slides. There's some settings that I have to change in order to demo it properly, so it's easier to just do the slides. Although actually I can, maybe I'll show you this first. Okay, let's try TSN. I do have a TSN account anyways, but if you want to watch TSN for free, you can go through the exercise of trying to session hijack me. So anyways, you can see lots of cookies are set. And then there's some other stuff here. And you'll see that they're actually blank. Okay, so there's other websites that are trying to set cookies, but my browser's not letting them set cookies. That's because I have certain privacy policies in my browser, and they're actually just the default ones. So they're turned on. If I go and turn those off, then you'll see that there are other cookies that come down with other websites, which I'll do in a second. Okay, but for now, let's just look at what does a cookie actually look like. So here's all the domains that TSN is pulling content from that would like to set a cookie. So they're sending those set cookie headers to my browser for all of these domains when I go to tsn.ca. And if I load one of these, it might load like some JavaScript, and then that JavaScript might connect to more websites, and then more might come down as well. Okay, so this isn't necessarily a complete list. This is just my first try at getting a bunch of cookies. So if I go to tsn.ca, this is all the cookies that TSN is setting on my browser. So this is the list of them. So you have the name, so you can see they call it different things. So they have like U at SID is probably like some sort of session ID kind of thing. But then other things will be for other stuff. There's a slide somewhere, but I might as well mention it now. Cookies, they aren't just used for session IDs and for tracking. There's other little things that they're used for. Let's say I go to a website, like I go to Concordia, and I say, I want to see the French version of Concordia, right? I don't log in or anything like that. It will set a cookie, and the cookie will be like called language, and the value of the cookie will be FR for French. My browser will store that. Concordia will say, remember that for a year. And then next time I go to concordia.ca, right, it will, my cookie will go along for the ride, and it will say, oh, this user wants the French version of it, so I'm just going to show them the French version, okay? So that's another way that cookies are used. Or, like some websites have like light mode and dark mode. You could set dark mode, it changes the graphic interface. That could be sticky. It could remember using cookies that you always want the dark mode until you switch it back to light mode, then it will switch the cookie. Okay, anyway, so these are the values, the names of the cookie. These are the actual values themselves. The values can be anything the server wants. So sometimes it's like some sort of like random password kind of thing, like especially for a session ID. So you'll see something that looks pretty random. Sometimes it might be like an encoding of something. So if you did a hex decoding or a base 64 decoding, you might get something meaningful. And sometimes you can just like read what it says. So like true, right? SSC, I don't know what that means, but it says true. Or session, you can see there's some JSON. So it has success, true, probably, and then maybe some other things. So the cookie values, yeah, like I say, they could be anything the server wants to, however it's programmed to read them. So sometimes they make sense and sometimes they don't. Okay, the next thing is what's called the domain. Now the domain is, we're already on www.tsn.ca. That was the website we went to, okay? When TSN sends us a cookie, we write down that we were on www.tsn.ca when we got it, okay? But there's also a domain inside of the cookie, okay? The domain inside the cookie may or may not be identical to the domain that you're visiting, okay? So there could be slight differences between the two. And what this is going to impact is, when does this cookie get sent back in the future? Okay? Does it only get sent back when you're exactly visiting www.tsn.ca? Or is it going to get sent in other conditions? So for example, let's say I go to www.tsn.ca. It sets this cookie called GAT. I have no idea what that means. Okay? Later, I'm going to images.tsn.ca. Do I send that cookie or not? Okay, we have to decide. I wasn't on exactly images.tsn.ca when I got the cookie. I was on www.tsn.ca. But if it's like my session ID, TSN probably wants to have me logged in across all its different subdomains, right? So it would want to share that cookie across its subdomains. But that's not strictly true, depending on it. So what the cookie policy does is it gives websites control over when the cookie should get sent back. And the way they put it is in this domain, and there's going to be some rules about it. But in general, you can see a couple different things. So if you see a .tsn.ca, it means it will send it back to anything .tsn.ca or just tsn.ca itself. Okay? So images, it's kind of like a wild card. So it means it will match anything here. Okay? If I want to only send it exactly to www.tsn.ca and not to any other subdomain, then I have to specify that as the domain here. So I put exactly this. Now it has to be an exact match. Okay. So if there's no dot out in front, then it's an exact match. And then this is probably a mistake, a programming mistake, but it basically says send it either to www.tsn.ca or any subdomain of that. So like images.www.tsn.ca. Most websites they don't set their domains up that way. So that's why I think it's probably a mistake. You usually don't have subdomains of www, but technically you could. But anyways, it basically says any subdomain of where I am, you can set that cookie, okay? So you can set it, you can have the cookie sent to all your siblings, you can have it set to subdomains and to the exact domain. And I think there's a slide later that goes through like all the different permutations. You can also specify what's called a path, and that says the cookie will only get sent not just when they're at www.tsn.ca, but when they're at, say, www.tsn.ca slash, MLS soccer slash, whatever. Okay. So if they're on that path of the website, you'll send the cookie. If they're on tsn.ca, but they're not at slash MLS soccer, then you're not going to send that cookie as well. Okay. Again, I've looked at lots of cookies. I've never actually seen the path variable specified. If it's just a slash, it means it's a wildcard. So any path is okay. So usually cookies are tied to domains rather than paths, but technically you can do it. Here's the expiration date. So you can see the browser will basically stop sending this cookie once it hits that expiration date according to the browser system's clock. So things like session mean that it deletes it when you close your browser. And otherwise, it's just a date with a time. I should have expanded that out so you can see the time, but I can do that here. So there's a date and a time. So you can set it to expire in 5 minutes or something like that. It doesn't have to be like far in the future. You have the size of the cookie. Okay, the size is really just the size of this, and this. Basically the size of all these fields put together. So you can see that this GAT cookie, that's a pretty small name. And the value that's being stored is pretty small. So as you expect, this is a pretty small cookie. So it's only 5 bytes. And then this one, you would have to expand it to see it. But you can see it has this big, long, random name. It looks like a big, long, random value. And so that's going to be like a big cookie because there's a lot of data there. So there's nothing magic about the size. It's literally just the amount of space it would take to encode this information. And then you have some security flags that the website can choose to set. There's 2 of them. One of them is called secure, and one of them is called HTTP only. Secure says that the browser, before it throws the cookie into a request, it should check and make sure that it's going over HTTPS. If it is not going over HTTPS, do not throw the cookie in. Okay? So things like session IDs, their passwords, their secrets, you don't want to send those over HTTP, so you should have that flag enabled. Whether you want to see the website in English or French, probably not that important. Yeah, someone could flip it in the middle, but you probably don't care that much about it, and so you might not set the security flag in that case. Okay. Now, websites will not necessarily use the flags wisely. Okay. So there are things here that look like they could be session IDs, like uit.sid, and the security flag is not being set by TSN. Okay, so very, very common. Actually, so basically what will happen, someone will code a website and they'll get some errors in terms of cookies. They'll go on like Stack Overflow. Maybe now they'll go to ChatGPT and they'll be like, how do I fix it? And people will be like, okay, here's what you do. First off, make this like the biggest possible. Right? So take your domain, don't put any subdomains, just put like .your domain. So it works for anything on your domain, right? Make it expire as far as in the future so you don't have to worry about it. And then turn all your security flags off because maybe that's stopping it as well, And then come back and tell us whether that worked or not. And probably it's going to solve the problem because now the cookie's being set in all cases. And so it's easy to see. Okay, so this is secure. The other flag is called HTTP only. Now, this sounds like it has something to do with HTTP and HTTPS, maybe, to you, because it says HTTP only. But this is not HTTP as opposed to HTTPS. This is actually HTTP as opposed to JavaScript. So when your browser creates a request, it either is creating a request because the user typed the URL in, the user typed in a link, or the user loaded an HTML document and it had a link in it, okay? All of that stuff is in the HTTP world, okay? The other thing that could happen is the user could load JavaScript, and the JavaScript can also initiate an outbound command. So it can say, go to the server, get this image, okay? But your browser treats requests that originate from JavaScript differently than requests that originate either from the user typing in or clicking a link or it being encoded in the HTML, okay? So it separates the two, okay? And so When the request is going out, the browser can tell you, did that come from JavaScript or did that come from HTTP? And you could choose, if you wanted to not allow your cookie to be sent if it originated from JavaScript. Okay? Why you want to do that, just wait a bit, and I'll show you why you might want to do that. But anyways, that's what that means. Okay? So HTTP only means that you only send it when it goes as a web request, and it has nothing to do with HTTP as opposed to HTTPS. So as long as it's going over HTTP or HTTPS, that doesn't matter. It's going to send it. Okay? But if it's being constructed by JavaScript, then it won't be sent, whether it's secure or not. Okay? So this is the JavaScript versus not JavaScript flag, and this is the HTTPS versus HTTP flag. Okay, now let's say I clicked on yahoo.com. You can see I have no cookies here. Why do I have no cookies here? Well, I'm on TSN and I'm not on Yahoo. And so my browser has this thing called prevent cross-site tracking, which is enabled by default. And so because that's enabled, this is considered cross-site tracking. Yahoo's trying to track me even though I'm on TSN. Okay, and so my browser is just not going to send my Yahoo identity to Yahoo. If I disable this and reload the website, now I see that, oh, there are cookies that are being set. And if I click on all these things, you see that there's lots and lots of cookies. And there's even more websites now somehow that want to set cookies once it realizes that I've turned this setting off. Okay, and so now there's lots and lots of cookies. Okay, how are we doing? Okay, I'll get through this slide and then we'll go on break. This is just I want to go back to this piece of it. So we talked about like when does the cookie get set and when doesn't it. So I'll just go through the sort of ins and outs of that. Sorry, I have some weird animations that take a while to run. Okay, so let's say this is the website that I'm visiting, okay, incs.concordia.ca, and it can set cookies, and the cookies can have any of those values that we saw inside of a cookie, okay? One of the values it's going to set is the domain, okay? So it can write different things in the domain. It could write incs.concordia.ca, but it could also write other things, okay? So let's say it puts in the cookie the domain encs.concordia.ca. Then when I visit this website, that cookie will be included, obviously, okay, because they match. If I go to, say, images.concordia.ca, concordia.ca, some other completely other domain like canada.ca, okay, that cookie is not going to get sent. Why is it not being sent? Because the domain I'm visiting and the domain that's set in the cookie is not exactly the same. If I put a dot in front, that means match exactly this or match any subdomain. Okay, so encs.concordia.ca is fine. Images.encs.concordia.ca is also fine. Okay, concordia.ca is not a subdomain, so it's not fine. Images.concordia, because it's not images.encs.concordia, right? It was .encs, so the encs is missing. So that's not going to, the cookie's not going to go in that case. And obviously, if it goes to some other domain, it's not going to go. Can I move up? So I'm at encs.concordia.ca. Can I set a cookie that's one level higher than me? And the answer is yes. So any super domain of me plus any subdomain. So basically anything .concordia.ca or concordia.ca itself is fine. Okay, so these are all fine. Basically, the only thing that won't be allowed in this case, this is the most permissive setting, would be a completely different domain, like canada.ca. Okay. Could I set my domain to be .ca? So I could go from encs.concordia.ca to concordia.ca. Could I go all the way up to .ca? And so the browser at this point will step in and say no. Okay. The reason you can't do this is your cookie is going to get sent to every CA. Imagine you did it for .com. Every .com is going to receive your cookie. You probably don't want to do that. There's probably no reason for you to do it. And it's just like, lots of people are going to do it by mistake. or because they want their two domains to talk to each other. But it's just going to end up polluting the cookie. There's going to be so many cookie values being sent with every request. It's crazy. We're not going to allow it. So it's just disallowed by the browser. So the browser will not allow this. That's a policy decision. They decided that. Okay, the next thing is a little trickier, but let's say that you're on encs.concordia.ca and it says, hey, I have this cookie, Canada.ca gave it to me, and I'm just giving it out to all the users that went to my website. Okay, am I allowed to set a cookie for a domain that's different than the domain that I'm on? I'll never see that cookie again. I'll set it to you, but every time you come back and visit me, you're not visiting Canada.ca. Okay, so I'm never going to see the cookie again, but could I at least set it on behalf of Concordia or Canada.ca? And then when you go back to Canada.ca, that cookie would get sent, even though I was the one that set it. Okay, so this is what we call a third-party cookie. So a third-party cookie is when one website A is setting a cookie for website B. Okay, usually it's only used for tracking purposes. That's mostly the only time it's used, and usually it doesn't break anything to turn them off. Okay, like the functionality of the website generally doesn't break. And so browsers very early, even before that like setting that I showed you in Safari, if you go back like 10 years, 15 years, there was always a disable third-party cookies setting that was there, and that's what this would turn off. Okay, the other thing was just path. So you could set a path constraint if you wanted. So let's say I set the domain to be INSE.concordia. I set the path to be /Clark. Then if you go to Manon's website, the domain matches. So his website's also at ENCS.concordia, but his path is different. And so that cookie would not get sent in that case, okay? It would only get sent to my path plus anything that came after. Okay, so again, paths not used very often, but they are there. It's a functionality of cookies. You can limit it to specific paths if you want. Okay, this is a good place to pause. So why don't we go take a 10-minute break, and then we'll pick up from there. All right, we'll get started again. Okay, so hopefully by now we've sort of explained all of this, but just to just reinforce what happens. I go to tsn.ca. I say, give me index.html. It sends it to me. Okay, I take index.html. I go looking through it, and TSN is saying like, go to Google and load this ad library, go to DoubleClick, go to Snapchat, whatever. And I'm going to all these websites. What my computer is doing is it's asking me to fetch something from that website, okay, like an image or a JavaScript or something like that. And so I do have to go out and get that from that website and get it back, okay? So what my browser is doing is every time I create these new requests out to these websites, then it's going through its cookie jar and it's trying to see, do I have a google.com or a cookie that matches google.com in my cookie jar? If I do, then it's going to throw the cookie in. Maybe I don't have one for Snapchat or DoubleClick, then that's fine, I'll just go normal. And for Twitter, I have a cookie, and so it gets thrown in, okay? So this is happening every time you go to a website. And again, when you go to one website, usually you're loading lots of content from resources from lots of different websites. And so cookies are being decided about all of that type of stuff. Okay, what's the cookie jar doing? It's just basically saying, for this outbound going to google.com, do I have any cookie in my cookie jar that matches that in terms of the domain? I'm making sure it's not expired. And then I'm also checking the flags as well. So if it's set to secure, but it's going over HTTP, then I won't put it in or whatever.
Does it make a read on the cookie?
Sorry, I didn't get the idea. Like, does it make a read? Meaning? So it reads it has the.
What if there was code embedded in cookie?
Oh, I see. So that would be a separate browser issue kind of thing. So it should treat it as content. It is content. If there was some way to put JavaScript, inject code into a cookie, and then when the browser tried to read it, it would execute, that would be like a vulnerability in the browser itself. But yeah. Yeah, so it doesn't, and it won't intentionally, it doesn't, cookies aren't for executable code. So anything that's there is yeah, it's just data, passive data. Okay, I have a little video that I made for Concordia a while ago. I'm going to see if the sound works. I don't know if it's going to work or not. It's not that important. I just throw it in because
but it's also an ad agency.
easy to do. I think in this room it might be set up that when I'm over HDMI, the sound only works over VGA or something weird like that. But I'm just see if I can. Oh yeah, it works. All right, so let me see what I can do about the volume of that. Sorry? Is it? I don't know. You tell me. Yes, it is. It is.
6 years ago.
Yeah, is that what it says? Yeah, 6. Yeah. I look exactly the same, so that's good. Oh, is this? Okay, so this is as loud as I can make it. But we'll. Oh no, it's not working. Huh. Okay, it did work. I don't know why it's not working. But anyways, okay, website, you can watch it yourself. It's on YouTube. The basic gist of it is that, let's say that I go to a website and, oh, I didn't notice that. Sorry. My bad. Okay, it actually is going to work now. That was the problem. You could have told me.
Hi there, I'm Jeremy Clark, a professor at the Concordia Institute for Information Systems Engineering. Today we're going to demystify internet cookies. So all of you have certainly heard about the delicious types of cookies, and most of you have heard about internet cookies. To help understand this concept, I'm going to tell you a little story about Alice. So let's say that Alice gets a brand new tablet. She opens a box, turns it on for the very first time. At this point, she's completely anonymous. She decides she wants to go and find some boots to buy. So she goes over to Google, and at this point a cookie's born. Think of a cookie as a serial number that websites assign to their users to track them around their platform. As Alice looks through her search result, she notices a pair of boots from her favorite shoe store and clicks on the link. By default, a cookie from one website can't follow you onto another website. However, Alice's favorite shoe company, like most of the top million websites, has a business relationship with Google. This allows Google's cookie to follow Alice through the virtual doors of the shoe store, like a little digital stalker. Alice gets bored of looking for boots, so she decides to go over to a message board to chat about her favorite show, Black Mirror. On the message board, she sees an ad for the exact boots she was just looking at. So what's going on here? Most of us think of Google as a search engine, but it's also an ad agency. The chat room in this case has outsourced its ads to Google. And because Google has a cookie that followed Alice from the search page to the shoe site and now to the message board, it knows exactly what ads it can serve to Alice that she's likely to click on. Using cookies in this way is prevalent on the modern web. Of the million most popular websites, Google can trace you across about 50 to 80% of them, while Facebook can track you across a third. Now, all of this may sound very scary. You should know that cookies are primarily used for advertising. However, there are more nefarious uses. For example, websites have started selling digital dossiers to political campaigns for micro-targeting. Now, you may be wondering what you can do to stop this. The truth is, it's pretty much impossible to live a cookie-free existence, as cookies also serve practical functions that make the web easier to use. However, there are some small tweaks you can make to your browser settings to help protect your privacy. First, you should disable third-party cookies. Second, you should enable Do Not Track, which prevents companies that are compliant with Canadian law from using cookies to trace you. The third thing you might use is private browsing mode, which gives you a fresh identity, sort of like when Alice turned on her new tablet for the first time. This is why digital privacy is such an important issue moving forward. And that's how the cookie crumbles.
Thank you. That was Concordia that put it together. So, yeah.
Yeah, I have a question.
Yeah.
Instead of me going to this route,
Sorry, say it again.
instead of me going to this route, to this manual setting for the cookies for me to block, is it not better for me to download and install the Ghostly app blocker extension?
Yeah.
It makes more sense. And besides, that one has more features rather than me going to disable the.
Correct. Yeah, it's easy to say you have your browser already, it's already there, don't do anything. But yeah, that would be even better advice. But people are less likely to follow through with it. But yeah, that's exactly what those extensions are for. So yeah. Okay. All right. So what happened in this case? What was the video about? So it's the idea that websites can trace you across multiple websites. And so the basic idea of it is I make a request. Say I go to lululemon.com and I send a request to it. And there's some shirt that I'm looking at, whatever. So Lululemon knows who I am. They can set a tracking cookie. And they can also, they know exactly what shirt I'm looking at because every shirt is on its own website. Okay? So it knows what I'm looking at. Now, Lululemon could outsource, they run ads on other websites. Okay? And so the ad agency could say, hey, you know what, wouldn't it be great that when we run your ads, if we recognize that the user that's looking at your ad was previously on your website, and then we could show them the exact shirt that you were looking at or something like that. And it would be more personalized. It would be more targeted at them. They're maybe more likely to come back and buy it if we do that. And so Lululemon says, that sounds great. What do you need from us? And they say, well, it's pretty easy. So just here's a little bit of JavaScript. Put it in your website somewhere. Every shirt on this website has an ID, yeah, and you're just going to pass that along with the JavaScript. So when Alice's browser runs the JavaScript on this page, this is the item number that gets sent. But if she's looking at a different shirt, same thing happens, just the item number would change. Okay, so Agile.1 is receiving these requests for the JavaScript. There's a little parameter on the end that has the item number, so it can write that down. Okay, and so then what Agile 1 will do is it will say, okay, I haven't seen Alice before, but I'm going to set a user ID for her. We'll call her 55. Okay, and then it sends back the JavaScript, and Alice runs the JavaScript. And I don't know what it does beyond just passing this information back and forth. Maybe it does something, maybe it doesn't. Okay, so that's all fine and good. And so Agile 1 in their backend database, I should actually show it, but now in their backend database, they say, okay, I have this user 55. I don't know who it is. It's just some user, but they were on the Lululemon website and they were looking at item 9483. That's all I know. Okay. Now Alice goes to CBC, and CBC's okay, we're sort of government funded, but we also need to make money, and so we're going to have ads. And this Agile 1, that's a great ad agency, so why don't we use them? Okay, and so it tells your browser, it sends the news article down to your browser, and then it says, go load ads from Agile 1. And as CBC, I don't know what ads they're running. It doesn't matter to me, right? If someone clicks on their ads, then I'll get a pay. The Agile 1 will pay me some money, but I might care a little bit. There's some ads that I might not want it to run. like depending on like things that are, I don't know, political in nature. There could be controversial things or things like that. But in general, it's like I'm not looking at the ads themselves. I'm not setting the ads. I'm not deciding it. I'm just farming this out to an ad agency. And so Agile 1 says, okay, there's this user, Alice is coming. She's requesting ad.js, which is my ad library, my code for serving up ads. And what Alice's browser is going to do right before it sends this request is it's going to be like, okay, I'm about to send this request to agile1.com. Do I have any cookies for agile1.com? And then it will go back and be like, oh yeah, I actually have this cookie, right? Agile1 set this cookie in the past. And so we'll say, okay, I got to slip that in real quick. That's my job as the browser. I found a cookie that matches, and it sends it off to agile1.com. Okay, Agile1 looks at this. It says, okay, some user wants ad.js. That's fine. Everyone wants it. That's what I'm going to serve up to them. But I know who this user is. It is someone that I've seen before, right? I gave them user ID 55. And then I'm going to go in my backend database and I'm going to look up user 55. And then hopefully it's written down all the different websites that it's seen this user at and what items they were looking at. Okay. And if it does, then it can say, okay, I know who this user is. I know what item they were looking at. So guess what ad I'm going to show them? I'm going to show them an ad that has that exact shirt in it. Okay. And now you might actually click on that because they're betting that you were looking at the shirt because you actually had some interest in it. Okay. And now I'm just reminding you. And I could show you an ad for a car instead, but why not show you like the exact thing that you were looking at before? It seems like a little more targeted. Okay. Now this only works because both Lululemon and CBC use the same common ad agency. Okay. If they use different ad agencies, then that information wouldn't get passed across. Okay. But as the video showed, something like 75% or 80% of websites use Google somewhere on their website. Usually because they have good web developer tools and they'll show you traffic. And let's say you want to find like, what was the Google search that someone typed in to go to visit your website? Google will give you that information in exchange for you running some JavaScript on your website from their domain that's going to set cookies and track users. Okay, so it's sort of a trade-off that you get. But if you're in the business of having a website and caring who your users are and what their demographics are and things like that, you're probably going to want to get that information from Google because it's pretty valuable. All right, now this leads to another feature of cookies, another thing that you can use cookie for, which are called cross-site requests. So the idea of a cross-site request would be, let's say we go back to this article, or sorry, this idea of CBC having a news article, all right? And let's say that at the end of the article, CBC's like, if you like this article, here's a thumbs up button, you can click on it. And if you click on it, what it will do is it will like this article on Facebook for you, okay? All right, so what CBC.ca does is they basically put that like button, which is a bit of JavaScript, and it comes from Facebook.com, and it puts it in the HTML file itself. So the HTML file will say, okay, Alice, you've just downloaded index.html. You're not quite done yet. You have to go get this JavaScript from Facebook. All right. Now, if the user is logged into Facebook and they have a session ID with Facebook, then even though they're visiting CBC, they don't even know that the Facebook like button's there necessarily. They haven't scrolled down that far. They are going out to Facebook and asking for an ad, or sorry, a JavaScript, not an ad in this case, a like button. And so their browser is going to put whatever Facebook cookies they have in the browser's cookie jar, it's going to go along for the ride. Okay. So now Facebook is like, okay, I know who this person is. All right. I know this is Alice. If CBC passes me the article that they're looking at, I even know like what article they're looking at. Okay. And so what they could do, well, they'll check their backend and they'll be like, okay, this is Alice. I know who they are because they have this cookie value and I assigned them this cookie value. Okay. And then what Alice can do, it doesn't show it. I should develop these slides a little better, but let's say she actually clicks the like button. Okay, then it will send some JavaScript or a request or something that says, okay, the user clicked the like button, all right? And Facebook will be like, I know who the user is because that cookie ID is there. And I know what article they're looking on. And so what Facebook can do is they can actually make you like the article on Facebook itself. Okay? So in other words, you were on CBC, you liked an article, you never left the CBC website. All you did was click the like button, the thumbs up button at the bottom of the article, and it actually updated Facebook on your behalf. Okay? All right, without you going to Facebook and finding the article on Facebook and putting the URL in, none of that. You can do all that from CBC's website, okay? So we call this a cross-site request because you requested a resource from Facebook even though you were on CBC. So cross-site meaning that you crossed over from CBC to Facebook and you asked, it was a request that you sent. So that's what the word means. And then the idea is that your cookie goes along if you're logged in. All right, and then Facebook knows who you are. Okay, any questions about cross-site requests? So cross-site requests are very useful. They make the web a lot easier to use. They make it easy to integrate different things into different websites. You can do things on other websites even though you're on a different website. Okay, but they are a little dangerous as well. Okay, because the user doesn't really know that that their logged in session to Facebook is going off to Facebook when they're on CBC necessarily, okay? And so there might be a way that we could exploit this as attackers. Before we talk about that, well, I want to talk about one other thing. We've already seen it, I've sort of showed it to you, but I just want to make it explicit. There's this architecture sometimes called RESTful. Most of the web works this way now, almost all of it. Let's say I have a URL like this. So this is actually a real URL. I can maybe click on it. Google.com search question, query equals soccer, and page equals 10. Okay. What does this URL mean? So let's just parse. Well, let's just start from the beginning. So https:// what does that mean? Okay, it's going over SSL. It's encrypted. www.google.com, what does that mean? We're going to the domain Google. Okay. Then we have /search. Okay, that's probably their search tool or whatever they've named it. Okay. Now we have this question mark. What does the question mark mean? Okay, so I'm going to put some extra information or data on the end of this URL. And it's not meant, you're not meant to go to the website search question mark, like it's not part of the name of it. The name of the website you're going to is search, but this extra stuff is just, it's kind of going along. It's extra attributes that go along for it, okay? So you can kind of, the website will read this, but it's not going to try and send you to this URL. It's going to cut it off at the question mark and send you to that URL. And then the rest of it is information that it can use to show you the most relevant thing at this URL. So here, again, you have key value pair. So you can name it anything you want, and then this is the value. So you have something called query, and it equals soccer. And if you want to have more than one attribute, you just put an ampersand, and you can put lots and lots and lots. Okay? Query equals soccer, and page equal 10. What do you think that this would mean if you clicked on it? So what is Google? Okay, above and beyond everything else, it's a search engine. Yeah? All right, so I click on this. What am I, do I just get Google? What do you want to search for?
This is essentially searching for soccer and displaying the 10th page of search results.
Okay, so if I went to Google and I typed in soccer, I would get certain responses, okay? And then it usually gives me pages. Now I think it does more of an infinite scroll thing, but anyways, it used to give you like pages. And so this would take you to page 10, okay? So when I'm on, after I've searched for soccer and I'm on page 10 of it, this is what my URL looks like, okay? So basically what my query was and what page I'm on is being tracked by the URL, okay? This is as opposed to tracking it by the backend database. So the backend database could say, you could go to Google and say, okay, what do you want to search for? And you put in soccer, and then it updates its database and says, okay, user with this cookie number is searching for soccer. Show them the first page of results, right? Then I say, show me the second page, and Google's like, okay, I don't even know what you searched for, but let me go back into my database. Oh, I see your username in my database. I see that you were searching for soccer. right? And so it's keeping track, the website itself is keeping track of all the information, okay? When websites track all the information, we call it state. Just a general computer science term. That's the state. So the state that you're in, or the state of where you are, and things like that, okay? What we'd like to do is we'd like to get rid of state, okay? State is bad because the website has to store it. At some point it has to delete it. It's complicated. So what we'll do instead is we'll take the state and we'll put it in the URLs themselves, okay? So when I say I'm on page 9 and it's giving me a graphic interface on the website, and there is the option to click to the next page. When I click to the next page, I go to a certain URL that's in the HTML of that website that I'm looking at. That URL will be pre-programmed with page equals 10. Okay, so it will be already in the URL of the page. I'm on page 9, and the link to page 10 will have page 10 in the URL. Okay, when it shows me the queries for soccer, it has query equals soccer in the URL, as well as all the URLs that are already in the website of things that I could click on. Okay, so now the state of where I am, I'm looking at the search results for soccer on page 10. That's like inside the website that I'm looking at. I'm remembering it because I have that website loaded in my browser. The server doesn't have to remember it. Okay, if I copied and pasted this URL and sent it to you in an email, and you clicked on it, where would you end up? You would end up looking at the search results for soccer on page 10. Even though you never typed in soccer, you didn't look at page 1, 2, 3, 4, okay? You just jumped immediately to the results for soccer at page 10, okay? That's because the website doesn't remember anything. It doesn't remember who you are or what you were looking at or anything like that. All it does is it looks at the URL, and whatever the URL tells it, it assumes that you got there somehow. So probably the way you got there was because you were previously at the URL query equals soccer page equals 9 and you click next. Or maybe you're at page equals 11 and you hit back. I don't know, right? But anyways, it doesn't keep track. It doesn't keep track of your state as you go through, okay? So the web works this way. All the, like where you are and all that stuff, what you want to do, the actions on a website, like a search is a kind of action. All that stuff's just put in the URL, and the website just looks at the URL and then says, okay, I know what you want to do. Does that make sense? Okay. All right, now let's put these two things together. So we have this idea of cross-site requests, right? So you can click on a Facebook like button from CBC's website, never leave CBC, and as long as you are logged into Facebook, it will like that article on Facebook. Okay, so that's cross-site requests. And then we have this like RESTful architecture as well. Okay, when we put these together, we get something called cross-site request forgery. Okay, so cross-site requests themselves are good. They're good. They're not a bad thing. But cross-site request forgery is bad. That's taking it and turning it into an attack, a spoofing attack. Okay, so here's how it works. First off, the adversary has to lure you to a bad website. Okay, so they have to trick you into visiting a website that they control. How do they do that? Maybe with a phishing email or an SMS message or something like that. I don't know. But somehow they get you to a bad website. Or it could be like they have like ads that are running on another website. Like it could be something inside a website. But anyways, they're controlling like what you're doing. All right. And so normally if you go to a bad person's website, an adversary's website, your browser should protect you. Nothing bad should happen. It's not good. I'm not advising you to do it. But in general, like your browser shouldn't, you shouldn't get a virus from doing it if you're not actually downloading anything. It should be generally safe to go to it. But anyways, okay. So what I do is I go to the website, evil.com. It sends me back index.html. I load it. And then it says, okay, I want you to go to this URL, this URL, this URL. Okay, so one of the URLs it sends me to, for example, bank.com. And it says, go to bank.com and request the URL account question transfer $100 from Alice to Eve. Okay, so this is a RESTful URL. Okay, it's basically saying It's kind of like the URL that would be created if you went on the bank website and you're like, I want to do one of these Interact e-transfers. I'm going to send it from here to here. And then when you click the button, this is the URL that gets sent to the bank. And the bank is like, okay, I don't know who you are or anything like that. Like I wasn't keeping track that you logged in and went to your checking account and then you clicked this because I'm not keeping track of any state. I just see that now you're at the point where you want to do this e-transfer. And so the only thing I care about is, do I know who you are or not? How do I know whether who you are or not is just based on your cookie value. Okay. So if Alice is logged into her bank when she visits evil.com, because it's a cross-site request, the browser is going to drop her cookie in to that request. Okay. So her cookie goes and the request goes to here. And the bank is like, okay, I just got a request from Alice who is logged in, has a valid session ID, and Alice wants to transfer $1,000 from Alice to Eve, okay? And it will do it. It will make the transfer go through, all right? So in this case, it's a forgery because did the user want to send the money? No, right? Alice didn't even know that this was happening. She doesn't, they're not even like images that are being displayed on the website. Like this is just back end, her browser talking to the bank server because evil.com tells her to go there, okay? So there was a lot of cross-site request forgeries. It still exists today, but it's been largely mitigated. I'll show you how. But yeah, for a long time, this would happen. And the bank would have to be set up in such a way to accept this. And banks are a little more conservative and they don't always implement the modern web stuff. And so it was hard to actually get a bank to like go through with this. But there were things like on social media, for example, if you just wanted to get someone to like a post or like post something or retweet it or whatever, you could often do that through RESTful stuff. So you would just lure someone to your website and then it like boom, 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 a bunch of messages would get sent. And then all of a sudden you go back to Facebook and you'd see that you'd liked some article that you never liked or shared something that you've never shared. And people actually assumed that they were hacked. They're like, someone hacked my Facebook and they posted a bunch of garbage to it. My password is compromised. But probably their password was fine. It was just a cross-site request forgery. So they went to a bad website and then the website was able to do it. But now that they're not on that website anymore, they're actually safe. Their password is okay. But there was a period where everyone's Facebooks were getting hacked or whatever. But that's because of this. Okay, how do we fix it? So one thing we could do is we could say, let's go back to this like stateful computation. So I'm not going to believe that Alice wants to send this money unless if I saw Alice first logged in, then she clicked on her checking account, then she constructed the transaction, put in all the fields, and now she wants to send it. Okay, so if I can follow her through all those steps, right, then I'll believe it and I'll send the transfer. But if she just jumps in at the middle and says, I want to send it, but I haven't seen any traffic from her before or after, then I'm not going to believe it. Okay, so that's the first way that you might do it. The problem with it is now you're going back to websites tracking users and keeping a lot of state. Okay, we don't like that. We like agile websites that are light and nimble. And so could we keep the benefits of RESTful while also locking down this attack and preventing this attack from happening? Okay, and so it turns out there's actually a very simple solution that's pretty elegant. Okay, what the solution is notice that in this picture, okay, this request works, right? Because the cookie value is correct. Okay, so if the cookie value wasn't here, let's say Alice was not logged into her bank, then this would not work. We all agree, right? Okay, so it only works because the cookie value is correct. Okay, the cookie value is being put there by Alice's browser, right? So Alice's browser is just doing it silently, it's throwing it in. Alice doesn't even know it's happening. Okay, does the adversary know that Alice's cookie value with bank.com is 55? No, it doesn't. Okay, it said go to bank.com and it gave the URL, but the cookie's in the header. It's not in the body itself. Okay, and so and the cookie was put in by Alice's browser. Okay, after she downloaded index.html from the adversary. Okay, so the adversary, and then this gets securely transmitted to bank.com. It doesn't go back to evil.com, it just goes to bank.com. This is why cross-site requests are generally considered safe. It's because you're sending the cookie to the website that you're supposed to be sending it to anyways. I can trigger you to start sending your Google cookies to Google and your Facebook cookies to Facebook, but your Google cookies are still going to Google and your Facebook cookies are still going to Facebook. So it doesn't seem that dangerous, okay? But anyways, the adversary doesn't know what this value is. Okay. Does bank.com know what this value is? It does because it set it. Okay. If you are actually on the real bank.com website, who would be putting these values into the URL if you're actually visiting bank.com? How do these values get put in the URL? Well, bank.com is putting them in the URL. Okay. So what bank.com can do is it can put your cookie value in the URL. So when you go to bank.com, it says, okay, I know who you are. You're logged in. For all these like RESTful URLs, I'm also just going to throw your cookie value in there as well. Okay. And I know it. You know it as Alice, and that's fine. Okay. And it's there in the URL. Now, what happens when we want to do this cross-site request forgery? Okay. The adversary will send you to this URL, but they can't put your cookie value at the end because they don't know it. Okay? So then the bank will reject it. It will say, okay, I see this RESTful architecture like URL. It looks great, but it's missing the cookie value. I don't believe it. Okay? Now, if you actually logged into the bank and you constructed this transfer, because you're doing that from within the bank's website, then the bank's going to ensure that this cookie value is in the URL somewhere. And so the transfer will go through when you get that URL from the bank will put it there and then the transfer will go through. But if you're getting this URL from some other third party that doesn't know your cookie, they can't put the value there. And because they can't put the value there, then it's not there and then the bank's not going to accept it. It's going to reject it. Okay. So you see this a lot in URLs. And if you look at URLs, yeah, you'll see like your cookie value. If it's any kind of thing where you're logged in and there's session IDs and things like that, you'll see cookie values in the URLs themselves. Okay, is that clear enough? Yeah.
You can better call it API keys.
Yes. Yeah. API key. So API keys are slightly different. That's what you mean, right? Yeah.
Yeah, for REST API, to identify user, its API keys are used.
You're saying API, right? Yeah.
API.
So API keys are more like, they're almost like a permission token. Like say there's some like database and you can download data from it, but you have to pay, right? Then what they'll do is they'll say, okay, we're going to give you a key that's unique to you. And if you throw it in the URL, it goes in like a RESTful architecture, then we'll accept the URL and we'll send you the data. But if you don't have the API key or it's wrong or it doesn't match any of our records or it's expired, then we won't give you the data. Yeah. So it's more like a permission token. So it's more like a password, but API keys have nothing to do with cross-site request forgery. Yeah. They are something that you stick in URLs as an attribute, but they're not, they don't solve this particular issue. Does that make sense? Yeah. Yeah.
So this attack is assuming that when I click on that link, it's gonna automatically transfer the money. But what if like the bank has some like another password to like enable the transfer? Will it work?
Okay, yeah, so there's a couple pieces that need to be in place for this attack to work. So one is Alice has to be logged into the bank. The second is that this needs to be sufficient to actually put the transfer through. Like just visiting this one URL once will make the transfer go through. If the bank has like a password or something like that, then what will happen is in this confirm message, it will instead say enter your password. Yeah. And then the JavaScript that evil.com is consuming will consume that response, but it can't, it could show the user a field to put their password in, but the user's not going to put the password in because they don't know anything about the bank. Yeah. And the adversary doesn't know the password, and so it's not able to do it. So you could do it that way. And this is a very good point. We talked about, like, if I can steal your cookie, I can hijack your session. If there's no protection like this on these URLs, then I can do cross-site request forgery. So those are two ways that I can use your cookies against you, okay? And websites realize this, and they realize that it's probably easier for me to steal your cookie or get you to misuse your cookie than it is to steal your password. And so a lot of websites do have it set up where, for example, let's say I'm using GitHub. I can do basic commands logged in, but as soon as I want to do I want to delete a repository or do something like more dangerous, it will make me put my password in again. Yeah. And so or like say I'm in Gmail and I want to do some sensitive thing, like I want to change my backup email, it might ask me for my password again. So now it's common on the web that there is kind of levels of access where if you're coming in with a cookie, you can access a lot of features, but if there's certain settings, like say you want to change your password or something like that, we're going to ask you to authenticate again in order to do that particular thing. Yeah. So banks could do that. They don't, as you know. It would be kind of annoying though as well if every time you want to do an e-transfer or something like that, you have to type your password in. But it is another valid response to it.
Because the bank in my country, they did that.
Okay, yeah. So then that would protect against this particular website, this particular attack, yeah. Okay, other questions about this? So this attack is kind of complicated. You might not get it, or it kind of makes sense that why I'm saying it, but anyways, make sure that you understand this attack and why this prevents it. Okay, so a summary of cookies themselves, I should say cookies. So cookies are useful. They do useful things for you, right? They keep you logged into websites. They remember that you want the English version of the website or whatever. So this is personalization of web features. Cross-site requests aren't bad in and of themselves. It's nice to be able to like an article from the article's website itself without having to go over to Twitter or whatever, X, Facebook. The cons of it is that session hijacking. If I can steal your cookie, it's kind of like stealing your password. Okay, it's not exactly the same for the reason I just explained. Okay, so with a cookie, often websites will limit what you can do with a cookie, and they might ask you for sensitive things to re-enter your password. So in order to do the most damage to your account, I would probably need your password, but I can still do a lot with just your cookie. I can read all your email, I can respond to people, I can do all sorts of things. They're used to track users across different websites, and that's it. Okay, any final questions on cookies? Okay, good. So next week we'll talk about JavaScript. So it's another sort of can of worms, but that will be another browser policy. So I'll see you all next week.